Yes, we do.
Okay. So the topic I'm going to talk about is common strategies to test IoT for different industries. Now, we all know what IoT is, and few years back in one of my conferences, people were talking that IoT would be the next big thing. Like everyone will be using IoT and all other stuff. But actually, I realized that we are already using IoT everywhere. And the most simplest form of IoT is your smartwatches. Everything is working on sensors. We all are wearing these smartwatches, whichever company you talk about. And then the data that this smartwatch is producing, we are just accepting that data. So if the smartwatch is showing that my heart rate is, let's say, 82 per minute, without any test, I'm just saying that, yes, it is 82. If I am running and my steps count or my calories count, it shows on the watch, I just take it. That is the basically what IoT devices and IoT as a technology has invaded us. Whatever you think about, whatever you talk about, whatever modern technology infrastructure that we see everywhere, it has some aspect of IoTs. So from smartwatches to connected cars, the Tesla cars that we talk about, everything is IoT based. So in my presentation, I'll just try to give you the applications where IoT is there around us. And then as a tester, what are the new type of challenges that come in front of us? Okay. So common strategies to test IoT for different industries. Before going into the actual application, let's quickly see some numbers which will give you more idea of where I am taking you. So this graph, it has these red lines and then it has these white lines on the top. The number of red lines is how the number of IoT devices are increasing in this world from 2015 till 2025, 10-year span. And the white lines are the basically non-IoT devices, your mobiles, your laptops, your, let's say, pagers, handhelds, all the iPads, right? If you see, in 2015, it was roughly 3 times the mobile devices and laptops than as compared to the IoT devices. And if you come to this year, 2022, the number of IoT devices have overtaken the number of non-IoT devices. And by year 2025, it almost, it is just opposite. So now the number of IoT devices are roughly double than the non-IoT devices. This is the growth. This is the amount of devices that are coming into the market and getting used by all of us. Some dollar values here. So in 2017, it was expected that the IoT market across the world was about $170 billion, which is a huge, huge number. But in 5 years, 2022, the number has changed to this value. Now, if you are a tester, if you own a company, if you are a senior manager or these kind of roles, you have to get some amount of this value, which is important. Because if our companies are not doing businesses here, then it's already losing something. And as a testers, we have to be prepared ourselves that what will happen when our company will get an IoT project. Are we ready? Are you as a tester ready? Do you know how to test an IoT device? Is this the same as testing an e-commerce website? You should ask these questions. And I will definitely answer most of these in my presentation. So this is a number just to give you an idea where the world of IoT is going. Now, these are certain applications which we already know. And when I put all together on this slide, now you know that how much IoT is inside our lives. Smart cities, wearables, smart homes, cars, health, retail, supply chain, farming. You name any industry and there is some IoT there. That is the power of IoT happening. Now, the first question comes in mind is, what has happened in the last few years which has made IoT this popular? So before IoT, there was another revolution that happened, and which was the mobile revolution. when entire world has at least one mobile in their hand. So initially, not everyone had a mobile, but then slowly what happened is the mobiles, the electronics, they got smaller, they got more powerful, they got cheaper, and it is widely available. So initially we thought that mobiles are only present in the big cities. Then the mobiles went into villages. Then the mobile went into each and every person's hand, whether he is a big industry owner or if he is just selling a fruit on your streets. But he has a mobile. So electronics got smaller, powerful, cheaper, and widely available. This is the first step that happened towards IoT revolution. The second step, IoT cannot work without internet. If internet is not working, IoT devices will stop. So the entire internet infrastructure across the world, it has become strong and it has become matured. So we talk about 1G, 2G, 3G, 4G. Now we are talking about 5Gs and 6Gs. Internet is becoming stronger and stronger and stronger. Even the broadbands in our home, I have seen internet in my home when just to download a 5 MB file, 5 MB small file, it took me so many minutes, 5 minutes, 10 minutes, sometimes even 15 minutes to download that file. I've seen that time. And today, just to download a 3 GB file or 2 GB file, it's a matter of just a couple of minutes. That's how strong internet has become. And finally, every IoT device has to be given an identifier, a unique identifier. But if we are talking about billions of IoT devices, how we can give them billions of unique identifiers? So we have selected a scheme which is called as IPv6. This has increased the number of identifiers from 4.3 billion addresses earlier to 3.4 into 10 to the power 38 addresses. You know what this number is? So 3.4 followed by 38 zeros. We can't even read the number. How many trillions, billions, millions, something, something. And an analogy is given that if every atom on this earth is given an address, still you won't finish all these 3.4 into 10 to the power 38 addresses. So all these three things combined together has fueled this IoT revolution. And that is why the entire world has entered into using IoTs. This is again a very simple graphic which will show you that in few years of time, if the world population is like 7.6 billion, there will be approximately 6.5 IoT devices per person. Now you again start thinking from a tester's point of view. If end users is 7.5 billion, that is the number of end users. But the devices are almost 7 times of that, 6.5 times of that. So as a tester, how to scale my testing to these levels? Your software is not going to be used by 1% or 10% or 50%. It is going to be used by a couple of million people. You have to scale up, and that's where the challenges start coming. So in simple, outside these numbers, what exactly is IoT? If the simplest model is you have a dashboard in your hand, which is your mobiles. Then you have this cloud infrastructure, which has all the data and algorithms processing and everything takes place. And then the devices, and these are the smart devices. Any device which existed earlier and now it is called a smart, then it is IoT enabled. So you have houses, now you have smart houses. Television, smart television. Phone, smartphone. Watches, smart watches. Means these are connected devices. These are IoT enabled devices. They are collecting data and pushing into the cloud. All the processing happens in the cloud, and then the appropriate results, they are pushed on your dashboards, on your mobiles. Because your mobiles are powerful, they can handle that data. Because the internet is very strong, it is always connected. And that's how this entire network works. This is a simple definition which I took from Google, but this actually explains the same thing. Let's come to the testing part, and I'll give you a very simple but example where you can easily relate to. We all love coffee, right? So you guys, your morning has started. I am already in my afternoon. So you all must had your first coffee or 2 coffees already. Now this is a simple cappuccino machine. if I want you to write a test case to get a coffee from this machine, what will be your tests? You go to the dispenser, you select your preferred option, which coffee you want. You put a cup under that nozzle. The drink is poured inside your glass or cup, and then ultimately you enjoy the drink. Now you repeat these steps again and again, and you will always get the same coffee, same taste, same amount of milk, same amount of caffeine, everything. What does that mean? Same experience every time. There will be no variety of experiences that you will get. If you press the first button, you will get a different kind of coffee. You press the second button, you get a different kind of coffee. You keep pressing the second button for entire year, you will always get the same amount of coffee. This is the non-IoT coffee machine. Now let's go to the IoT model. So what we have changed, how a non-IoT thing gets converted into IoT thing. Two things we have to ensure. First, you have to bring dynamic UX. And second, you have to produce valuable data. If your machine, whatever machine you are using, if it is not producing data, then you cannot apply a lot of innovativeness to your machine. And the entire essence of having an IoT machine is failed. So I give you a model. This is the model of a new coffee machine. So this center machine, this has become the new IoT machine. Now what happens is, when you go in front of the machine, your face gets clicked. So there is a camera on top of this machine, which will just click your face screenshot. Instantaneously, that face photo is pushed to cloud from the step number 1. It goes to cloud. The cloud has thousands and thousands of faces stored. A very quick face matching algorithm happens. It will search the database for your face. And as soon as it finds that, it will send all the data. So your name, your age, your gender, right? All your personal data, it comes back to the machine. The machine also has a voice speaker and voice recorder. So as soon as the name comes, it will just say, "Hello, Vipin. This is Monday morning. Would you like to have your strong cappuccino with two shots of coffee?" And you are like, wow, the machine knows that every Monday morning I take 2 shots of coffee. How does that happen? Because last Monday when I came in and I used this machine for getting my coffee, my data gets recorded. My data is pushed to the cloud with my photo. Second time, my just photo went and the photo gets matched and the data comes back to the machine. And that data is used, it is translated into a voice, and the voice is shown in front of me. And you are like, wow, this machine knows me. And you are instantaneously attracted towards the machine. This is a personalized machine for you. So for me, it's cappuccino. For you, it might be a lighter coffee. Or for the third person, it may be a different kind of coffee. And then if on Tuesday, you take a different type of coffee, and on Wednesday, you take a different kind of coffee, the machine remembers everything. So what is happening now is, whenever you go in front of the machine, at what time you are going, on what date you are going, the machine finds some pattern relates to that, and it gives you those options. Up to you, you want to take that option or you do not want to take that option. But whatever you do today, it will also get recorded. So the user accepts the persona, the beverage comes, interaction and consumption happened, and all the new data that you did today, it again gets stored in the machine, in the cloud. So that's how this entire evolutionary learning process, it keeps on happening. The data keeps coming in, the data keeps processed, and data keeps stored. How much data is collected just from this coffee machine? And you will be amazed to look at this data. Context is collected. What is context? The technology, camera, sensors, the demography, which country, state, city, the place, are you in a mall, in office or restaurant, the seasons, time of the day, which day, weekday, weekend, and the usage. Are you first in the queue or you are last in the queue? Because when you wait for a long time, we started getting impatient and the expressions come on our face. Even those are also recorded. And not only this, What is the age group? Are you a kid, young, or you are a old people, male, female? Are you happy, sad? How your face speaks? It will use the interactions also. Which options are displayed? So ultimately, all these kind of data, you just put every of these category as a separate data. So you will have a big data table which has lots of fields and lots of data there. And this is just for 1 cup of coffee. If you have 15 cup of coffees for, let's say, the entire week, 15 different records will get saved in the cloud. This is for 1 week, and then 2 weeks, and 1 month, and 1 year, and many years. Just imagine the amount of data is getting saved. So you will always have a different experience based on this collected and analyzed data. That's the difference between an IoTized machines and non-IoTized machines. So what come the challenges then? So IoT is the IoT in hardware then? Yes, IoT has a lot of hardware. But then to run that hardware, you require a lot of software. Yes, we write codes. And then how these are connected? So we have lots of connectivity things. Your broadbands, your internet speeds, your Bluetooths. So then what's the challenge? You need to test everything. IoT is not a single application. It is not a single machine. It's an ecosystem of things. So when you plan your testing, you need to test this entire ecosystem. That's the first challenge. We are not used to do these kind of testings. What has changed then? Data is coming from all the sides. That's the first biggest problem for me. How to save that data? What type of tests to be carried on that data? We are used to have like 10, 15 records, an e-commerce website. I have a person logs in, select 5 or 10 different products, save into the cart, right? Apply some credit cards and everything, and the testing is complete. This is not that simple. You have to test carried out in the field, not in the labs. That's the second big problem. If you are wearing this smartwatch, if you are, let's say, driving a Tesla car, you are testing a Tesla car, you have to take the car out in the street and you have to test whether if there is a turn, the car actually turns. If there is a red light, the car stops without a driver. I cannot create a exact real life scenario which is outside, inside my lab, on the machine, in my room. You need huge rooms. Tesla car is big, right? And you have to ensure that the user experience also comes in the testing. It has to be considered. Second problem is you need to have experts for these things. So for example, if you are testing a smartwatch, right, which is calculating your number of steps, are you as a tester actually wearing the watch and then running outside in cold or in hot? You guys are sitting in a very cold place, right? I am sitting at 45 degrees Celsius right now. I cannot run outside. It's too hot. But then how to test it? You need a runner. Similarly, if I am making an IoT device which has to be put inside the heart of a heart patient, you need someone who can wear that chip, and then I monitor the data. I will not be going to put that chip inside my heart. So you need specialist people. And finally, you will need subject matter experts also. I am not a doctor. I do not understand the data that is coming from the heart, whether the blood is pumping in fine, whether it is pumped out fine, the capillaries and all that stuff. You need a doctor to explain those things to you. Otherwise, how you understand the medical devices, how you understand the pharmaceutical companies, how will you understand the farming things if you have not done those things? So that is also a different kind of testing we are talking about. Now, just see this sample test case. This is from the Jira, which I use. This is one of the test cases from the customers, and I have taken their permission to display this. See the step number 4. Have test subject begin jogging. So test subject is the person who is wearing the watch and he will be started running outside. So he will start jogging and he is maintaining a 6 to 8 minute mile pace for 30 minutes. Then maintain proximity, 15 feet. So I am now in a car or on a bike or something, and I am just 15 feet away from the guy. So the guy is running, I am very slowly driving. He has the watch, I have the computer, and the data is coming on my computer. And then once he stops after a point, we will see what is the data in the watch. And then we will see what is the data in the computer. And then we see whether the data is same or it has some 2 to 5% variation or it is completely different. So you have to record each and every kind of these things. And this is just a simple watch example. I do. Think about the bigger things. So the accurate challenges for a tester. The use cases are very complex and you require real-time responsiveness. So if my heartbeat is showing wrong on that IoT device, the data should go to the doctor's computer immediately. If the data goes after 10 minutes, the patient might have died. So real-time responsiveness, your internet speed is very important here. The performance needs for fast responses. Performance tests have become very, very important now for IoT-based devices. Data security, definitely. Your personal data is now getting produced by these devices and pushed on the cloud. Your medical history, your watch usage, your car driving styles, everything is getting stored in clouds. Without data security and privacy tests, you are not going to use those devices. So as a tester, we also have to perform a lot of securities and privacy testing. Then protocols. I have not talked about protocols so far, but I will be talking now for 2 or 3 minutes on that. So all these devices, they interact with each other and they come from different vendors, right? So there may be someone in India who is making devices, and then there is someone in Russia who is making the devices. Both devices communicate with each other and they communicate with protocols. So you also need to do the protocol testing to make sure you and me have used same standards. Our endpoints connect with each other so that the data moves flawlessly. Then a lot of volume, variety of data gets produced. You need to apply all those kind of testings. There are different kinds of applications and devices present in the market. So that is also a challenge. And then the sensor interactions. Every device is a sensor which produces data. They interact with each other. They talk to each other. You have to test those also. What are the tests that can be performed? So first question that comes in mind here till this point is, okay, I am in a pharmaceutical industry. I am testing, let's say, a medical IoT device thing, right? My test cases are different. You are testing a smart car. Your test cases may be totally different. So do we need to test each and every scenario in every application? I am giving you a slide which you can see, save, click a photo. This slide will give you the basic tests that can be applied on every layer, irrespective of what domain you are working on. And then you can apply your industry-specific tests for that. So largely, there are 4 areas in IoT. There is an application layer, there is a services layer, gateway and network layer, and finally the sensor layer. So when you are talking about the application layer, you can apply these 5 kinds of tests. Do the localization testing, do the API testing, do the functionality testing, do the compatibility testing, and finally the usability testing. These 5 can be applied anywhere because every IoT has an interface. So the application layer is always present. At the services layers, you have to apply the interoperability. Are the services changeable? Can we replace each other? The API, of course, 2 services communicating with each other, API has to be there. Functionality, of course. And then you come to the network layers where you have to check the network connectivity and you have to check network compatibility. If I am at my home and let's say I am using my broadband and after some time I have to go out. So I just put my phone on, let's say, a hotspot and I go outside. My IoT should continue. From my broadband, I just move to the phone's internet. And then I reach to the office where, let's say, there is a dedicated fiber line is coming. So different kinds of internet, they keep switching. But the compatibility and connectivity should never break. And finally, at the sensor layer, you need to test the functionality, of course. Security, yes. So in all, you have to focus on performance testing because we talked about real-time responsiveness. You need to talk about security because of the data. You need to talk about the compliance because different countries have different rules. If you are, let's say, right now in Britain have the GDPR, which is the Global Data Protection. So they have rules on data. America might have different rules. Russia might have different rules. So you have to test on compliance. You have to test on interoperability. If your device is not working fine and you buy a device from a different vendor and you put that device there, will the network still works? Are the devices and softwares and protocols operable with each other? And finally, the privacy and analytics. I just give you some real life examples from healthcare project test approach, which we are using. And I'll show you what type of tests we carried out there. When I talked about usability testing, first thing important for me is the devices have to be portable. So if one device is not working fine, it should be immediately replaced by another device and it should work. Then anything which, any notification, any error message from the patient, it should show immediately on my phone, on my laptops, anywhere where I am. If I'm the doctor, there is a patient and anything wrong happens, the data should come in the form of a notification. That is very, very important for me. And then it should be able to display on each kind of device also. It's not that, okay, on an iPhone, it is working fine, but on Android, it is not working fine. Everything should be logged. So when something happens, as a software people, we can see the logs. And finally, the data, it should be displayed. I just told you about that. Security testing. I just told you about, quickly go through that. IoT is data intensive. Lots and lots of data gets produced. So security is very crucial. Data can be stolen from the cloud, but data can also be stolen from those endpoints where two devices communicate. Similarly, you have to apply lots of encryption and protection techniques on the data. And the UI should be password protected wherever it is possible. So these are the requirements. But what has happened is, from a tester point of view, I have to test all of them. Then the third kind of testing, the connecting testing. So as I said, for healthcare sector, it has become very, very crucial. Systems should be up all the time. It cannot be that, okay, there is a 5-minute downtime. In your 5-minute downtime, the patient might have suffered a lot of medical issues. So system should be up all the time. If sometimes the system goes down, then there has to be a mechanism so that the manual monitoring begins automatically. And when the system gets up, all the data which is recorded in the manual monitoring, it should be pushed back into the system. So all the data should be present in the cloud at the same time. Pilot testing, I already explained that to you. So you cannot do all kind of lab testings because IoT is itself an ecosystem. It is not an application. If you do a testing on a limited number of users, but when you expand this to a bigger scale up, if you want to scale up these things, it might fail. So let's say this healthcare project system, we originally developed it for 200 users. So there is a hospital which has 200 capacity. So for 200 people, the software worked fine. But then those hospital guys, they said that we are expanding our hospital to a capacity of 2000. Will your system work? And we tested and it failed. So we have to do a lot of testing, lot of development again to make sure that that 2000 people are working fine now. But then if 2000 is taken to 20,000, what will happen? It might fail again. And then performance testing, I just told you, your system should be scalable. So test for few people, but then also test for large number of people. And all the important parameters, system usage, power usage, the temperatures, they have to be monitored. Because IoT devices are not present in a room. IoT devices are scattered, this building, next city, and they all are connected wirelessly through internet, through satellites. So performance has to be there. Compatibility, IoT system is a mesh. It is an ecosystem. It has operating systems. It has browsers. It has devices, hardwares. The devices come from different generation. And it has communication modes, the internet connectivities, Bluetooth 2.0, 3.0, it will keep changing. When all these kind of things are there, they all have to be compatible with each other. Regulatory testing, depending on which country you are, you have to apply certain tests there. And finally, the upgrade testing. As I said, IoT is a combination of protocols plus devices, plus operating systems, plus firmwares, plus hardwares, network layers. You need to regress test the whole system whenever any device changes. If let's say I change the operating system in the above link, in this chain, I remove this operating system from here, the connection breaks. If you replace the operating system with something else, if you replace the browser with a different browser, you need to test the protocols till network layer, everything again. So your regression test becomes so crucial. But the amount of test cases is so large that you have to do a lot of automations here. So all the testing types we have seen earlier, performance testing, security testing, functionalities, API, they all have come together here. And don't forget the cloud. Your data is present in the cloud. So there are lots of data testings also happening. Your developers might are writing lots of algorithms on the cloud data to process the data correctly. That will also come under the testing parts, right? In the end, I have just told you that there are brilliant things being happening on IoT, and it's a huge market, lots of money, lots of challenges, lots of technology, but IoT is also very dangerous. And I'll just take 1 minute of yours and just see this video.
Vipin, unfortunately we cannot we cannot hear the sound of the video, so just skip it.
Okay, just give me a minute. I think I need to open the sound from here. Share sound, yes. And I'm playing the video again. Sorry, this one.
My husband and I would randomly joke sometimes, like, I bet these devices are listening to what we're saying.
Until recently, Danielle's home was completely wired up in every room with the Amazon Echo. Her family used the Alexa app to do everything from turn up the heat to turn off the lights. But Danielle told us via Skype that 2 weeks ago, their love for Alexa changed with an alarming phone call.
The person on the other line said, "Unplug your Alexa devices right now."
That person was one of her husband's employees calling from Seattle.
We go around and unplug them all. He proceeded to tell us that he had received audio files, recordings from what was going on in our house.
Danielle says her Amazon device in her Portland home recorded a private conversation and sent that recording to a random contact, which happened to be the employee in Seattle.
At first, my husband was like, "No, you didn't." And he's like, "You're sat there talking about hardwood floors." And we're, "Oh gosh, you really did."
Danielle listened to the conversation and she couldn't believe someone 176 miles away heard it too.
I felt invaded, like total privacy invasion. Like immediately I'm like, I'm never plugging that device in again. I can't trust it.
That's the scary part of the device, but this is just to give you an idea that from technology perspective, where we are going. So with this, I come to the summary of my presentation. So the testing approach is different, and you might have realized now that it will take you a lot of learning to go this way to test IoTs. There is more of a testing as a user approach rather than requirements. The requirements will be simpler. The testing domain is huge. Integration testing is very, very crucial. As I said, there are so many things present, so they all integrate with each other. And finally, it's challenging. But as a tester, you should also feel the excitement about that, because you will get to test all these things, the devices, protocols, hardwares, which I named earlier. So feel the challenge, but remain excited. And that will take you ahead in your IoT testing journey. These are some images from some very good, I would say, sites which I referred to when I was preparing this presentation. You can just take these QRs and you might go to these websites and learn more about these IoT testing. And finally, it's both of us, me and my wife. We are authors of this paper. She is a computer professor and she has a daily job today. So she couldn't be part of this presentation, but I deliver this. And you can follow us on my LinkedIn or Twitter, or you can send me an email if you want to discuss anything in future related to IoTs or any other QA stuff. With this, thank you for hearing my presentation patiently, and I am open to all kind of questions.
Thank you for your presentation. My question is, do you often encounter hardware problems rather than software problems? when testing IoT?
Can you just speak the first part again?
Do you often encounter hardware problems rather than software problems when testing IoT?
I'm sorry, but you froze again. So
let me repeat it for you one more time. So
yes,
Vipin, while testing IoT, do you often face the hardware problems or the software problems? Which one is more frequent?
In fact, I would say frequent are both kind of problems. Software is more because software is constantly being worked upon. People keep on adding more code, more functionalities to it. Hardware problems come sometimes because hardware once made, you are not going to reopen it and change it every day, right? But when it comes, it becomes a larger problem because many times you don't even think that, okay, this is my, for example, this is my watch, right? If I am using it, then I'm using it. It will not cause problems every day. Software causes problem every day, but they get fixed also very easily. Hardware problems are less, but then they become big when they actually come.
We have 2 online questions. So the first one, could you please give some examples of failures or misfunctioning bugs when testing wearable devices and standalone devices with remote control?
You are saying that some examples of bugs when testing devices?
I guess yes.
So you want to see the hardware bugs, right? Or the software ones? Devices means the hardware devices, I believe.
So it's online question. So
okay.
This isn't my question.
I just...
yes, the question is about wearable devices, so about the hardware and about
hardware devices.
And about the, again, hardware devices, standalone devices with the remote control, like Alexa and so on. So the most interesting bugs regarding these 2 types of devices.
So, right. So for Alexa and these kind of things, I just show that video, right? That itself becomes one of the biggest bugs. IoT devices, look, just try to visualize this thing. There are devices all around us, hardware devices in our house, your thermostats and all other stuff. There is one big problem which happened on internet that was called Mirai bot issues. So devices are scattered across the internet and the bots, they just keep moving inside the internet infrastructure and they see what are the bots that are unattended. Unattended means which have loose logins, passwords and other stuff. They capture those bots, the bots capture those devices and then they make those devices produce wrong data. So I have not seen actually testing that in my hand, but in my customer's place, we have actually seen that, for example, it was very cold outside. Your house is supposed to automatically warm itself, but the temperatures were not changing in the house. And they have to call those guys who actually came and manually changed those temperatures on that. So thermostat is supposed to work automatically. If it is cold outside, it should make the house hot and the other way around. But the thermostats stopped working. Similarly, this Alexa thing I told you. For the devices specific problems, we all rely on the device producing correct data. If the device, I saw a strange problem where a device is not getting electricity because it was connected to an electric circuit. It was not getting a proper power supply. So it is producing data, then it stops. Then it produces data, then it stops. So this start-stop thing which is happening, it is sending data, then it is not sending any data. So that half data which entered in the cloud, it got half processed. And the results which came back to the handhelds, it was completely out of the thing. No one actually visualized that that kind of thing also happened. So that is also one kind of issue that we observed.
Okay, thanks. And the second question from the same author, and it will be the last question since we are running out of time. What mocks can we use when testing IoT? So like stubs, like not using actual device, but something to replace it. Like in software testing, you know? Or when you replace the actual service with a simplified one, that is, like we call it mock or stub. So could you please
okay.
give us some examples?
Can you just, I understand the question, but can you just repeat the first line which is written with you?
What mocks or stubs can be used
Mhm.
while testing IoT devices?
Yes, yes. So there are a lot of, I would say, softwares available which help us in doing a lot of virtualizations. I would say we can use a lot of stubs there. The name again, I am not coming straight off in my head. We prepared our own stubs that we know. Dimitri, I can message you that thing a couple of minutes later if it just comes into my mind.
Okay, I will try to deliver the answer to the one
Sure,
who asked.
sure.
Okay, I think we are out of time. So Vipin, now it's time to choose the best out of 3 questions who will be awarded with the T-shirt.
I will be the first question that the gentleman sitting in the back. Yes.
Okay.
That was a nice question. And also because he's present here, right?
Great. Thanks a lot.
This is always a good. Thank you. Thanks for
see you at the next
opportunity. See you.
conference. Bye.
Yeah. Bye.